In this video, we're going to introduce ourselves to the next part of section 5.5, the law of sines. It's a law that we're going to use to solve non-right triangles. And we're going to find out that there's going to be certain cases where this thing is going to be perfectly aligned for us to solve a triangle. In section 5.6, we're going to learn a separate method to handle some different types of conditions that the law of sines can't satisfy. That'll be the law of cosines. But for the moment, the law of sines is what we're going to focus on. You will have this formula, just like you'll have the area of a triangle formula as you work through tests and quizzes. We're not going to prove how this works, but we're going to take it at face value. And what it says for any triangle, the ratio of the sine of the angle and the length of its opposite side, its associated side, those ratios are consistent across all three angles. Sine of angle A divided by length of side A is equal to the sine of angle B divided by the length of side B equals the sine of angle C divided by the length of side C. So, where can we use this? Well, we're going to work with problems where we're going to give you a triangle and we're going to give you certain amounts of information. And your job will be to see, hey, particularly at the law of sines, do I have enough that I can solve the whole triangle? And we're going to see there's certain cases, depending on what you're given, that are going to absolutely allow you to do that. And the first case is when you are given a triangle in which you are told the length of one side and you know the value of two angles. Think about this for a second. When you know two angles in a triangle, you automatically know a third angle. I'm going to repeat that. When you know two angles in a triangle, you know the remaining angle's value. Why? All three angles need to add up to 180. Get the sum of the two angles that you know. Subtract that from 180, and you have the value of your third angle. And as soon as you have that, what would you be in position to do? And I'm going to just kind of star this very quickly. This is a little scoreboard that I use. Let's pretend I know two angles and I know a side. As soon as I know the two angles, I know the third side. I have a nice consistent ratio that I can solve for here. And because I know the ratio I need, and in these other two ratios, I already have one out of the two values, I can solve easily for the remaining piece. So that's the nice thing here. In the scenario where I have two angles and one side, I can automatically figure out the third angle. I automatically now know what that lovely ratio is between each angle's sine and its length. And I can take that ratio and apply it to my other two locations. That's the key here. So whenever you see a problem where you have two sides and an angle, you're going to be in pretty good shape. So here's what I've done with this first problem. I'm going to solve it kind of off to the side just to save ourselves a little bit of room. I have a triangle A, B, C. Kind of again looks equilateral. That's just by happenstance. What do I know? Well, I'm going to call this A, B, C because that's how I like to write my triangles. I know that angle A is 63 degrees. I know that angle B is 49 degrees. And I know that side C is 78. So let's look at my scorecard. I'm going to go over here. What do I have in this particular problem? I got A, and I got B, and gee whiz, I have little c. At the moment, I don't have enough to solve all my ratios. But what's the nice thing? As soon as I have two angles, I automatically know what this is. Simply, there's my calculation and my result, but I know that 180 minus 63 minus 49 equals 68 degrees. And so now I'm in very, very good shape. And I'm going to just solve here on this piece of paper as opposed to putting it down here. I know that the sine of 63 over A is equal to the sine of 68 over 78. 68 degrees over 78. That allows me, if I do some cross multiplying and other work, I can say that A times the sine of 68 So I'm going to show it all the way through this time. A times the sine of 68 equals 78 times the sine of 63 degrees, which tell me that A is equal to 78 sine of 63 over the sine of 68 degrees. So let's go ahead and work this through very quickly. Calculator on. 78 times the sine of 63. I'm going to just calculate that as an intermediate result. And I'm going to divide that by the sine of 68 degrees. I'm going to come up with 74.95. Let's just round that to 75.0. We'll go to one decimal spot. And I know for B, again, cross multiplying would say B times the sine of 68 equals 78 times the sine of 49. I'm going to be able to say that B equals 78 the sine of 49 degrees over the sine of 68 degrees. Again, just using my cross multiplying up here. What's that going to tell me? 78 sine of 49. I take that answer, divide by sine of 68. And I come up with 63.5. And I can go ahead and fill in the rest of my triangle. Little b, 63.5. Little a, 75.0. It's a nice triangle. By the way, little sanity check. What's my biggest angle? 68 degrees. What's my biggest side? 78. Hey, it's opposite that. 63 is the middle. 75 is the middle length in terms of my sides. My smallest angle is 49 degrees. My smallest side is 63.5. So bottom line here, two angles and a side give us everything we need to work with because we can compute the third angle. And once we have a third angle, we are home free. We're going to do some other work with some other circumstances where we'll have different things given to us. I'm going to have us look at a little bit of algebra very, very quickly here because it's going to lead into what you'll see a little bit further down the road. So I'm not going to have you worry about the sine of B and the sine of C. I'm just going to worry about the value of B and C. We'll just treat them like normal integers. Pretend here, and this would be, a ratio, three different ratios. Take a look at this. I've been given one numerator and two denominators. Can I solve this whole thing? Well, I hope that you would agree that I could at least solve for B, 8 over 16. Hey, that looks like 1/2. I ought to be able to here say that B is equal to 6. So I can get that second ratio, fine and dandy. However, can I solve this third one? Not really. I can give you a whole bunch of possibilities, that's for sure. I could say big C is 7, little c is 14. I could say it's what? Big C is 20, little c is 40. I can give you a whole bunch of values, but I couldn't give you anything specific. That's an important point. Again, what I have when I go through these different ratios is going to allow me to figure out, can I use it to get all the way home? This little example here, nope. Take a look here now this time. I'm going to add one more piece. Again, just so you can see this. I have a ratio. I don't have a ratio here. I don't have a pure ratio there, but what do I now have? In each of these pieces, my middle one and this one, I have at least one of the two elements. What's that going to allow me to do? Well, that's going to allow me to go over here, and this time I'm going to be able to say that B equals 6, and I'm also going to be able to say that C equals 20. If I have the right pieces, I'm going to be able to solve, and that will apply to the law of sines as well. We're going to see one additional interesting wrinkle in a little bit, but for the moment, I just want you again to get your feel about working with ratios. When can you fully solve? When can you only, quote, kind of solve? Bottom line for what we're doing with this first piece of the lesson with section 5.5. If you got two angles and a side, you can solve the entire triangle. You will be able to do it. It's just going to be use your ratios, work, and be comfortable.